I will show you something of FLIR systems, of the new technology, new infrared cameras, and of course the new FLIR TG165. We will start now. First, I'd like to show you who is FLIR Systems. Of course, who am I? My name is Andreas Mühe. I'm Key Account Manager for FLIR Systems in Germany and responsible for Distrelec in Germany. So who's FLIR? I think the most important part is our headquarter, of course. We are based in Portland, USA. There is our headquarter, but the base for Europe is the place Stockholm in Sweden. There we are developing and producing the most important infrared cameras and thermal imagers. We have some other very important locations. For example, in Santa Barbara, USA, we are producing our own infrared detectors. It's the heart of an infrared imager, and we are producing this in our own company, Indigo. And of course, we are producing, for example, the small E-series you will see later in Tallinn in Estonia. FLIR is a worldwide company. We are about 3,000 employees, and we are since about 40 years in the infrared market, and in the infrared market we are world leader. So, the responsible persons for Distrelec, I like to show you. We have our boss Thomas Young. He is the sales manager for Europe and Central Europe. He's based in Germany and responsible for Germany, Austria, Switzerland, and East Central Europe. And the responsible persons for Distrelec, of course, me, Andreas Mühe, I'm responsible for Germany. Then we have one guy for Austria and Switzerland, it's Ivan Zaric. We have Andreas Völl, he is for Poland, Czech Republic, Hungary, and Slovakia. And of course, Paul van Loon for the Netherlands. So these are the persons who are responsible for Distrelec. Here you can find your contact person. Our main key of FLIR Systems is infrared technology. So the first question, why do we use IR technology? And I have some information for you. We are measuring temperatures. And we are using the infrared technology because we are measuring the temperature of objects which are energized. You are able to touch, but only once. We are measuring objects which are very hot. You can, of course, you can touch, but it's not very good for you. And we try to measure objects which are moving or which are very inaccessible. These are the key features why we are using infrared technology to measure temperatures. What's the advantage of an IR image or of an IR picture? You can see here heaters in an industrial environment, and this is the picture you can see with your eyes. Every single object, it's not so good to see, but every single one of these heaters has to have a high temperature. And with your normal view, you are not able to see if everything is working fine or everything does have maybe a fail. And this is only possible with an IR imager. Or the next example. We are looking at this corner of the house, and we are not seeing, is there any fail? And the infrared image shows very clear, there's something wrong. The camera cannot say, okay, it's humidity or there is a leak or something like this, but we can see there is something. The product family of FLIR in 2014, I'd like to show you, is this. We have small infrared cameras, like the small E-series on the left side, and we have very much more products, like on the right side the P600 series. The difference between these cameras is for the first time the resolution. We have a small camera with 80 to 60 pixels, and the biggest one does have 640 to 480 pixels. So this is the biggest difference between these cameras. For us, a new product family is a T&M, test and measurement family. So we have some clamp meters, we have a digital multimeter, we have an endoscope. This is our new product family. And of course, for all the products, we have accessories, we have pouches and cables and so on and so on. And for us today, the most interesting thing is the new TG165, our IR thermal pyrometer. So I think very interesting for us. FLIR spends about 10% of the turnover every year in internal research and development. So what to do with $155 billion? For example, the FLIR Lepton. We developed it last year, and what you can see here is the whole infrared camera. Of course, you can see the size. It's about 8 to 8 millimeters, and it's the smallest infrared camera without a screen, but this is the module. You can see the lens, and you do have the bolometer, the detector inside. And with this 80 to 60 pixel infrared viewer, we can create infrared pictures, of course, to find hotspots and to see where do we have a fail or something like this. And the first product we developed with the FLIR Lepton module is the FLIR TG165. It's the smallest and lightest infrared viewer of FLIR. Sorry? Gebe ich gleich rum. Yeah. This is the first unit with the FLIR Lepton module. And what do we have here? We have an IR pyrometer with an infrared picture of a bolometer. So it's a combination. We do have, on the upper side, on the FLIR TG165, we do have the Lepton module. And the downside, there is a pyrometer installed. And on both sides, we have alignment lasers. So with these lasers, you can clearly see how big is my measurement area. Because many pyrometers does look like this. And many people think, okay, I'm measuring this spot. But you are not able to measure the laser spot. You always have an area. And in the TG165, you can clearly see how big is my area. So you have to make a circle of it. So the most advantage you can see here, we have an infrared thermal IR pyrometer with the Lepton module and 80 to 60 pixels. With this 80 to 60 pixels, we are creating infrared images, and you save this as a non-radiometrical picture on an SD card on the top of the TG165. The temperature range is up to 380 degrees. You can measure the Lepton module, so the picture goes up to about 130 degrees. So this is what we can see and what we can measure. The accuracy is about 1.5%, 1.5 degree, depends on my object. Sensitivity, 100 millikelvin, and I think the most important thing is the distance to spot ratio. It's 24 to 1. So if we want to measure an object of 1 meter size, you can do this in a distance of about 24 meters. So the two lasers, they are framing the measurement area. It's the most important. So if you want to measure an object, you have to see if you are able to measure it because of the area you are measuring. The images are saved on an SD card. We have the connectivity to base it on a tripod. Some applications do need it. It's simply to use. It's very robust, and with every TG165 we do a 2-meter drop test, so if it doesn't work, you can throw it about 2 meters. So 499 euros before tax, it's the new price. The next unit we would have would be an infrared camera, the E4, and the E4 would cost 995 euros. So this is about a half of the small infrared camera E4. This is the TG165. So, any questions regarding the TG165? One question could be, Andre, what's the difference between the E4 images and the TG165 images? Both of them do have 80 to 60 pixels. So in an infrared camera like the E4, you are saving radiometrically infrared images. So you can take the image, go to your computer, and you can work with the pictures. You can see which temperature does every single pixel have. In this camera, we are saving non-radiometrically pictures. So the temperature I'm measuring now is saved, of course, but I'm not able to see the temperature of every single pixel. So if there are no questions, this was it. A small presentation regarding the TG165 and the FLIR infrared technology. And if you don't have any questions, I'm very proudful to be here. So thanks a lot.